Let me give an example of a system with a time delay. So we want to find the inverse transform of this z transform. X of z is equal to z squared all over 1 plus 3 z minus 1. And to it, we want to add z to the negative 3 all over 1 minus z to the negative 1. And it has an ROC of absolute value of z greater than 3. All right, so the way to do this is to break it out. Isolate that z squared, because this, in the parentheses, is something that comes right off the tables. Similarly, this is something that comes off the tables. In the tables, there is a transform that says a raised to the n, u of n, has the z transform of 1 over 1 minus a z to the negative 1. So that means we can identify a here as equaling negative 3. And this would be like applying a z squared. If we didn't have that z squared, we could take this part alone and say this has a transform of minus 3 to the n u of n. And similarly, we could take just this part here, if we ignore that z to the negative 3, and say here our a is 1, so that would look like 1 raised to the n u of n. And of course, this 1 raised to the n is more simply written just as 1. But what do we do with the z squared? The z squared means that we've shifted everything. There's a property that says if you have a x of n that has this z transform, then if you delay that by some amount, that's just like taking the original undelayed transform and multiplying it by z to the negative n naught. So here we can see that this n naught is going to be negative 2. So we add this positive 2, positive 2. And here our n naught is 3. And so we plug in 3 here, and we get minus 3. And now we've taken care of these z's. So our whole z transform is going to be negative 3 n plus 2, u of n plus 2, plus u of n minus 3. And of course, you can always do algebraic tricks to multiply this through, and you'll end up getting, let's see, this is equal to negative 3 to the n times negative 3 squared, which is 9, u of n plus 2 plus u of n minus 3. And I'd certainly take that too. I don't really think that this is any simpler or more complex. It takes out the exponent, but at the expense of adding in a coefficient. I would take either.